going to give you that page. Okay, you have to read that probability from the second page only. Second page only. The required probability is Z greater than minus 0.5. Minus 0.5. Right? Now here you have table. Now try to find probability Z greater than minus 0.5. Z greater than minus 0.5. Sorry, minus, just the value, minus 0.5, right? Not 95, 0.5. Okay, what is that probability? This one. Okay, you have the table. I have shown you a part of the table. It will be enough for you to read that probability. Okay, quickly find P. Is it greater than minus 0.5? You may have to use the symmetry of the distribution. Using the symmetry of the distribution, you can easily find this probability from the table. Not that you cannot read this probability from the table directly. Okay, directly you can't find it. Before reading the table, write the probability is greater than minus 0.5 using a positive value. Using a positive value. There you may have to consider the symmetry of the distribution. Okay. If you want, I can show you this diagram as well. Right. Now we want to find, is it greater than minus 0.5 now? This shaded region is required to be found. But if you consider the symmetry of the distribution, this region is similar to the region given in the right-hand side curve. Okay, 0.5. That means Z greater than minus 0.5 is same as Z less than 0.5 according to the symmetry of the distribution. Z less than 0.5. Now you can read this probability from the table, no? Because probability table values represent area under the curve left to the left of the to the left of the Z value 0.5, no? Understand? Area to the left of the point or the point 0.5. So what is that probability? Did you find the probability? Please tell me the answer. That should be what? 0.69146. No? Did you understand that example too? Yes or no? Please tell me. We have 25 participants, including me, sometimes more than that. So if you have any question in regarding example number 2, please ask me. Please tell me. Do you have any question? Did you understand how to find that probability? Huh? We wanted to find probability Z greater than minus 0.5. Negative values cannot be read from the table. No. Table has only positive values of Z. Therefore, we write this inequality of the probability as PZ less than 0.5. Is that correct? Of course it is correct. Why? It is because of the symmetry of the distribution. This is minus 0.5. This is similar to this probability because it is symmetry. Therefore, Z greater than minus 0.5 can be written as P Z less than 0.5. Now you can find this probability. You can read this probability from the table directly. 0.5. 0.5 is here, 0, 0. The decimal is 0. 0.50. That is equal to 6.69146. 0.69146. Okay. Right. Now see the next example. See this example. If Z is normally distributed random variable with mean 0 and variance 1, what is probability? Is it less than is it less than minus 0.76? You need to find this probability for the same random variable Z. Z means normal random variable with mean 0 and variance 1. So special normal random variable called Z variable or standard normal random variable. So you need to find probability Z less than minus 0.76. This probability, the small region. Since the table doesn't have negative values of Z, we are going to use symmetry of the distribution to find the required probability. So minus 0.76 Z less than minus 0.76 is similar to Z less than, it is not similar to this one. Okay. Okay, give me a second, I will explain it. Now we want to find P Z less than minus 0.76, no, right? Minus 0.76, this one. But if you look at that, if you draw the histogram or the distribution of the curve, that is like this. We need to find this region, small region. Okay. And this is similar to P Z greater than 0.76. No? This is equal to this. Is it greater than 0.76? Can we read this probability from the table? Can we read this probability? No, we cannot read this probability directly from the table. Therefore, Z greater than 0.76 is written as 1 minus PZ less than 0.76. Still it is equal to this, okay? Still it is equal to this. So 1 minus, read Z less than 0.76 from the table. What is that value? 0.76, 0.7. The second decimal is 6. This one. 0.76. That is 0.77637. Finally, you will have the probability that is 0.2236. Okay, 0.2236. Actually, in the diagram I have given here, these two diagrams are not similar. Okay, this Z less than minus 0.776 is not equal to Z less than 0.76. These two regions are different, but you may need this Z less than 0.76 to find the required probability, that is Z less than minus 0.76. That's why I have given these two diagrams. Okay. Z less than minus 0.76 is equal to probability Z greater than 0.76, and that is equal to 1 minus Z probability Z less than 0.76. Here I have written it clearly. Z less than minus value is equal to Z greater than positive value of the same value, and that is equal to 1 minus Z less than 0.76 probability. Okay, this probability can be found from the table, that is 0.77637. 1 minus that value is going to be 0.2236. Okay, you have to practice these problems at home. Now, look at example number 4. Example number 4. Now you have to find the probability when Z in between these two values. Minus 0.64 to 0.43. So how do you find this probability? The given probability, how do you find it?
Madam,
Yes.
example 3 එක explain කරන්න පුළුවන්ද?
Okay. Okay. Do I need to explain it in Sinhala? Yes or no?
Yes, ma'am.
Are there any Tamil students? Okay,
Yes, madam.
okay, I'll be using both languages. This exam, right? We want to find PZ minus 0.76. No, we cannot read this value from the table since the table does not have negative values. Okay. Therefore, we are going to change this inequality. Definitely, we have to convert this negative value into a positive value. Otherwise, we can't read. We can't use the table. Okay. So, we write, before writing that inequality, we will draw the, let's draw the distribution first. You know, Z is defined as a standard normal random variable, which is normally distributed with mean 0 and variance 1, which means the curve is symmetric about its mean. Right hand, on your right, you will have positive values. On your left, you will have negative values. Positive values, negative values. Okay. Now, minus 0.76 should lie somewhere here. Somewhere here. Anyway, it is on left hand side. Okay. Right. Minus 0.76. And Z less than minus 0.76 means we need to find the small shaded region. That's clear now. This required probability is equal to this small region under the curve, area under the curve to the left of 0.76. Is it less than? But we can't read this probability directly from the table. Therefore, we have to use the symmetry of the distribution. Now, can anybody tell me the similar region for this shaded region in the diagram, the similar region? This is equal to this small region 0.76. This is plus 0.76. These two small regions are similar. They are equal. Their areas are equal. Why? The distribution is symmetric about its mean 0. Z is defined as a normal random variable, no? With mean 0 and variance 1. So it is symmetric about its mean 0. So minus 0.76 the corresponding positive value is plus 0.76. So this small region is going to be the region given in right-hand side. Okay, so instead of finding this region, it's okay to find this right-hand side region. Now you can write an inequality for the right-hand side region. How? That is equal to Z greater than, not less than, greater than. This is Z that is greater than this 0.76. Clear? Now we want to find this probability. Still it is equal to this, okay? Now, still we can't read this probability from the table. Why? Probability, this probability table, the standard normal table represents probabilities to the left of the Z value, to the left. But we have here right now, because we have Z greater than. Therefore, this probability can be written as 1 minus P Z less than 0.76. නේද? මේ region එකෙන් මේ ටික අඩු කරාමනේ මේ පොඩි region එක එන්නේ. එහෙනම් 0.76 වලට වඩා අඩු probability එක හොයලා ඒක එකෙන් අඩු කරා නම් මුළු entire region එක එකයිනේ. මුළු එකෙන් මේ ටික අඩු කරා නම් මේ පොඩි එක එනවා. sorry මේක තමයි distribution එක. මේ නම් 0.76 ඒක තියෙන මේ වගේ හරියක අපිට හොයන්න ඕන 0.76 ට වඩා වැඩි ටිකනේ. වැඩි ටික ටේබල් එකෙන් රීඩ් කරන්න බැරි හින්දා අඩු ටික රීඩ් කරනවා. අඩු ටික රීඩ් කරලා ඒක එලිමිනේට් කරනවා. මේක එලිමිනේට් කරාම ඉතුරු වෙන්නේ මොකක්ද? මේ පොඩි රීජන් එක. එහෙනම් 1 මුළු එකේ ඒරියා එක එකයිනේ. නෑ එකකින් අඩු කරන්න ඕන Z less than 0.76. That is equal to Z greater than 0.76. Finally, it becomes Z less than minus 0.76. So that is equal to 1 minus Z less than 0.76. You can read that probability from the table 0.76. That is 0.77637. That is equal to 0.22 something, right? Yes, 22 something. 2236. Now, did you understand?
Yes, madam.
Okay, others? Others, did you understand that example number 3?
Yes, madam.
Okay. Now, let's move on to the next example. That is example number 4. Okay. Here we have a range from minus 0.64 to plus 0.43. And we are going to find this probability from the table, right? First of all, better to draw the required probability in a distribution like this. Otherwise, it would be difficult. Okay, so write this inequality or write this probability first and try to draw the distribution then. Now, minus 0.64 should be somewhere here on left hand side, right? Plus 0.43 is somewhere here. Why? It's a positive value. No, it should be on right hand side, right to the value 0. Minus 0.64 is left to the 0. Okay. Right. So you need to find these two regions. Minus 0.64 less than is it 0.43. Okay. Now draw the distribution This is 0. This is minus 0.64. This is minus, not minus, plus 0.43. You need to find this region. These two are not symmetric, right? This region is bigger than this y. This is 0.64. This is 0.43. So if you draw the corresponding z value, positive z value of minus 0.64, that should be somewhere here, 0.64. That means definitely this region is bigger than this. Okay. Anyway, we are going to find the entire region from minus 0.64 to plus 0.43. Okay. Right. Now, we can write this probability in this way. Z less than 0.43 minus Z less than minus 0.64. Is that correct? You might think here we have Z greater than minus 0.64 because this inequality has Z greater than minus 64. But here we have Z less than minus 0.64. Why? I'll tell you the reason. First, draw Z less than 0.43. This region represents PZ less than 0.43. It's clear. No? It's clear. This region represents probability of Z less than 0.43. Now I'm considering the region, the same distribution, right? These two distributions must be same. The same distribution, the size of the distribution should be same. Now I'm drawing the region corresponding to Z minus 0.64. Minus 0.64. So this whole region represents P Z less than minus 0.64. It's clear, right? Now you have determined these two regions separately. Okay. Now I am going to subtract or eliminate this small region from this bigger region. Okay. I'm going to subtract this probability from here. Or I'm writing this as Z 0.43 is here, and I'm going to subtract this Z less than minus 0.64 from this. Now that will be what? That will be what? If we eliminate this small region from here, finally we will have this region. This one, that is the required probability. Understand? Understand? So that this should be what? Minus 0.64 to 0.43. This region. First, we consider Z less than 0.43 and we eliminate this Z less than minus 0.64 region from that in order to find the required probability. Now, did you understand if we have this type of probability, how to write the inequality? We have P probability of Z when Z is in between A and B. A less than Z less than B. How do you write this probability? P Z less than B. First write this. Minus P Z. Do not write less than. I mean, you have to write less than. Do not write Z greater than A, right? That should be again Z less than A. Then only it would be correct. Understand? So if you have P, let's say we have B less than Z less than C, how do you write this? Probability Z less than C minus probability Z less than B. Okay? This going to be same as this. So we write probability Z less than 0.43 minus probability Z less than minus 0.64. Okay, right. Now we can find this probability from the table directly. Still, it's difficult to find this probability from the table because still we have a negative value. Okay, now let's change this negative value, or let's convert this negative value into a corresponding positive value. Okay, like this. This is Z less than minus 0.64. This is Z less than 0.43. And you have to eliminate the small region from here. Finally, you will have this region. Okay, right. This is how we write the inequality. P minus 0.64 less than Z 0.643 is equal to PZ less than 0.43 minus PZ less than minus 0.64. We have derived this expression first. Okay. Now, Z less than 0.43 can be read from the table. No. Therefore, please remain it as same. Don't change it. We can read that probability, right? Now, P is less than 0.43. The problem we have with the second term is less than minus 0.64. Now, Z less than minus 0.64 is similar to Z greater than 0.64. Is that correct? Is that correct? Now we have Z less than minus 0.64. No, that region is similar as Z greater than 0.64. Now you have to replace this term. Replace this term by this. Okay, so we write here I write the expression 64, but that is minus, right? We can read it from the table, so we keep it as same. Z less than 0.43 minus. The problem with this negative value now. Therefore, we have to consider the similar region. That is, this is greater than 0.64. So we replace that term by P is greater than positive 0.64. Okay. Now we have both positive values. Positive values can be read from the table, but still there's a problem with the second term. Why? Greater than probabilities cannot be found directly from the table. We can find less than probabilities. Ne? Therefore, we write the expression again. 3. Z greater than 0.64 is what? Z දශම 6 4ට වඩා වැඩි probability එක. මේකනේ හොයන්න ඕනේ. එහෙනම් මේක කියන්නේ මොකද්ද? මුළු එකෙන් මෙන්න මේ ටික අඩු කරන්න හරිද? ඒ කියන්නේ එකෙන් අඩු කරන්න ඕනේ Z less than 0.64 කියන එක තමයි මෙන්න මේ Z greater than 0.64 කියන්නේ. තේරුණාද? Therefore, open a bracket P is greater than 0.64 can be written as 1 minus P is less than 0.64. Now all the Z values are positive and less than type. If they are in less than type and positive, we can directly read these probabilities from the table. Now what is P? Is it less than 0.43? 0.43. 0.43. 43. This 0.43. 0.66640. 0.66640 minus the expression we have 66640 minus 1 minus P is less than 0.64. Is it less than 0.64 is what? 0.64. 0.73891. 0.73891. 1 minus that value. Okay. Now you can simplify this using a calculator. Okay. 0.66640 minus 1 minus 0.7389. 1 is going to be this. Okay, I have not written that term, but using the calculator, I think I have calculated these answers. Okay. Finally, you will have 0.4053. So this is the correct way to find that probability. I know you have to practice these examples again and again in order to understand the concept and the way. Okay. Still, do you have any problems? Any doubt? Yes or no? Did you understand how to find these probabilities? Okay, let's do another example. Okay. Another example from read this probability. Is it 0.5 to 0.75? Now you have to find this probability. Probability of 0.5 less than is it less than 0.75. Try to find this probability from the table. Point 0.5 and 0.75. 0.5 is this, 0.75 is this. Quickly find this probability and send me your answers. Okay, do it with me. I'm writing the solution. Do it with me. This is equal to, please correct me if I'm doing wrong, okay? Is it less than 0.75? Is 0.77337 minus, is it less than 0.5 is 69146. Correct? It's easy to calculate. Okay. Now do these examples with me. Now we have probability of minus 0.4 less than Z less than 0.6. Now do it with me. We do not change the first term as we can read that probability from the table. Now try to convert this negative value into a positive value. How? If you want, you can draw the distribution first. But I can write this probability without looking at the diagram. But if you want, you can draw the diagram like this. Minus 4 and less than minus 4, minus 0.4. No. So that is similar to greater than minus here. So I'm writing Z greater than 0.4. Again, I'm writing because we can't read this probability either from the table. So we write Z less than 0.6 minus P Z greater than 0.4 means this region means 1 minus this region. 1 minus P Z less than 0.4. Z less than 0.6 is what? 0.6. That is this 72571 minus 1 minus Z less than 0.4. That is this 65542. You can use a calculator to find the answer. I'm not going to solve it. Okay, so here we had two positive values. Here we have one negative value and one positive value. Now we will do this example. P minus 65 less than Z less than minus 42. Minus 42 is greater than minus 65, no? Yes. Yeah. Now try to find the required probability. Now both values are negative. Okay, doesn't matter. No matter the values we have here, we can write this as P Z less than minus 0.42 minus P Z less than minus 0.65. Right? Both are negative. That means we have to change both terms. We have to convert these negative values into positive. If you want, you can draw the shape of the distribution. Minus 0.42 is somewhere here. And is it less than? That means this region. That is similar to is it greater than 0.42? Minus is it less than 0.65 is similar to is it greater than 0.65, positive 0.65. Now we have converted our negative values into positive. Still, there's a problem. Why? We can't read these two probabilities from the table directly, since it has less than type probabilities. Here we have greater than type, no. So we need to convert this into less than type like this. Is it greater than 0.42 means this region that is equal to 1 minus is it less than, sorry. We need to find P is it greater than 0.42. Is it greater than 0.42? It is equal to 1 minus P is it less than 0.42. So I'm writing 1 minus P is it less than 0.42 minus, better to put a bracket because here we will have minus, plus, minus, plus. Okay. So is it greater than 0.65 means 1 minus P is at less than 0.65. Now both are less than type. We can just find these probabilities, or you can simplify it further before finding these probabilities. P is at less than 0.42 minus plus minus minus plus P is at less than 0.65. Okay, plus 1 and minus 1 cancel out. Finally, you will have P is at less than 0.65 minus P is at less than 0.42. This is positive, this is negative. Therefore, I'll write is at less than 0.65 first minus is at less than 0.42. Now you can read these two probabilities from the table. Okay. If you want, you can draw the diagram or the distribution like this. We need to find the probability is it greater than 0.65 and less than 0.42. No? This probability, no. This is symmetric as 0.42 to 0.65, this region. That's what we have got here. Is it less than 0.65 minus is it less than 0.42? These two regions are similar. If you want, you can write this probability directly by looking at the required probability. You can use any method. Anyway, finally, you have to get the correct answer. I'm not going to check each and every step, but you have to write it in correct way. Okay? Okay, so far, did you understand what we did during today's lecture? Yes or no? Okay, now we are moving on to a new part, that is standardization. I think we have 8 minutes more. We can discuss this standardization procedure, okay? Since we have 7 minutes more, right? Now, you might have heard your Z score of your A-level examination. Z score. What do you mean by Z score? Z score එක කියන්නේ මොකක්ද? All of you have a Z score, have an Z score. No? All A-level students have Z score value. What do you mean by Z score? Z value. Z score means Z value. Z means what? Z in statistics, Z has only one meaning, that is standard normal random variable, which means a normal random variable with mean 0 and variance 1. Mean 0 and variance 1. If any normal random variable with mean 0 and variance 1, it's named as standard normal random variable. Okay, so your Z score is like a Z random variable. Okay, I will come to that part later about your Z score. Now, let's discuss our topic, standardization. Standardization. All of the probabilities above, that means previously, were calculated for the standard normal distribution only n 0, 1. You may have noticed that in the standard normal distribution, the mean is always 0 and variance is 1. They cannot be changed. If you have any other parameters like mean 4, variance 2, mean 3, variance 5, likewise, if you have any other values for the parameters mu and sigma squared, You cannot use standard table yet. Okay. So if you want to use the same standard normal distribution table to find probabilities of a normal distribution or of a normal random variable, you need to know the process of standardization. Okay, right. Now see the given description. If we want to calculate probabilities from different normal distributions, we convert the probability to one involving the standard normal distribution. Understand? So we are going to convert a normal random variable into a standard normal random variable, and that process is called standardization. You cannot standardize any random variable, right? You cannot standardize any random variable in this way. You can standardize or you can convert only a normal random variable to a standard normal random variable, because standard normal random variable or standard normal distribution is a special type of normal distribution. That's why we can convert any normal random variable into a standard normal random variable. Did you get that point? That procedure is called standardization. Standardization, or we can say normalize, but we do not use that term here, okay? Only the term that we are using is standardization, which means converting any normal random variable into a standard norm into the standard normal random variable, because we have only one standard normal random variable, right? We have only one standard normal random variable. We may have several normal random variables, but we have only one standard normal random variable, which is normally distributed with mean 0 and variance 1. Okay, I'm going to give you the formula for that process. If you want, you can read these slides. I'm not going to discuss this slide. I will directly go back, move on to the method. The first step is you have to subtract the mean value first, and the deviation or the difference must be divided by the standard deviation, that is sigma. This procedure is called standardization. Okay, right. Let me explain this again. As we have 2 minutes, I will explain. Standardization. That means converting a normal random variable into standard normal random variable. That means any normal random variable with mean mu and variance sigma square is converted to a special type of normal distribution, that is standard normal distribution, and standard normal random variable with which is normally distributed with mean 0 and variance 1. This is how we convert it. Now x is going to be z, no? So z is equal to x minus expected value of x divided by square root of variance of x. I have discussed these terms earlier in chapter 3, expected value of x and variance of x. Expected value of x means mean of x, mean value of x, right? Mean value of x. So this is the correct formula for that. But here I'm not going to use this ex. Instead of this ex, I'm writing z is equal to x minus mu over sigma. Why? Square root of variance means standard deviation. The symbol for the standard deviation is sigma. Expected value of x is mu. Go back to the chapter 3 and check the definition of the expected value of x and the symbol we use to denote expected value of x. We use the symbol mu for ex. So this is how we convert any normal random variable into the standard normal random variable x minus mu over sigma, or x minus expected value of x divided by variance of x, square root of variance of x. Okay, right. Now go back to the presentation. Here we have the formula x minus mu over sigma. Definitely this x should be what? X should be a normal random variable. You cannot standardize any other random variable in this way. In this way, you can't. Okay. Definitely this x should be a what? Should be a normal random variable. Previously, x follows the normal distribution with mean, mu, and sigma squared. Now it follows the standard normal distribution with mean 0 and variance 1. After you standardizing this x into z, you might have, opportunity to use the standard normal table to find probabilities, to find required probabilities of x. Okay, right. Now, guys, do you have lectures now? 3 o'clock? Yes or no? Quickly tell me. Do you have lectures now? Yes or no? I'm not going to take much more time from you. I just need to explain only one example. Okay. I need to explain only one example. Hello, students, are you there? Are you there, students? Can you hear me? Okay. Some of you have lectures at 3:30. What about others? Do they have lectures at 3 o'clock? Okay, if you are not going to answer my question, I'll continue the lecture. I have to explain only one example from standardization, okay? The next part will be discussed later. Okay, example number 1. Suppose we know that the birth rate of babies is normally distributed with mean 3,500 grams and standard deviation 500 grams. What is the probability that a baby is born that weight less than 3,100 grams? Okay, so this is the question. First, you need to read the question very carefully and try to get an idea about the information given in the problem. What is the variable here? Suppose we know that the birth weight of babies. Variable is what? Birth weight of babies. And we know that the birth weight of babies is normally distributed. It's given normally distributed with mean this value and standard deviation this. So how do you write that statement according to the statistics? I can write it as how? X is birth weight, no. So X is normally distributed with mean 3,500 and variance 500 square. The standard deviation is given as 500. So the variance should be 500 square. This is what we are given about X. Now X is what? Birth weight. We are asked to find what is the probability that a baby is born that weight less than 3,100 grams, which means we are asked to find this probability that a randomly chosen baby is born with weight less than 3,100. We need to find this probability. Understand? We need to find this. Now, can you find this probability from standard normal table? No. Standard normal table can be used if we have this a random variable with mean 0 and variance 1. Those values tabulated for this distribution only. So you cannot read probabilities from that table to find here without standardizing it. That's why we need standardization. Now we are going to convert this x into z. How? Do it with me. We need to find this probability now. Write that probability. X less than 3,100. Now we are going to standardize. What is the procedure to standardize any normal random variable? X minus mu over sigma. Now I'm writing instead of this x minus mu less than. If I do any change to x, I have to do the same change into 3,100 as well. No? Minus. Now what is mu value? Here we will write the symbol mu since we have the symbol x. But right hand side we have a value no. Therefore, when you write the right hand side the expression, we need to substitute the value of mu. What is the mu? Mu is 3,500. Sigma is 500. No? So x minus mu less than 3,100 minus mu is what? This. Okay? That is P. P of. Now I'm divide the entire probability by its standard deviation, sigma. Now what is sigma? That is 500. Now here we have x minus mu over sigma. Now what has happened to this x? Earlier it was a normal random variable. Now we have changed this x into x minus mu over sigma, which is called z random variable or standard normal random variable, z. Clear? Z. Now 3,100 minus 3,500 means minus 400 divided by 500. Okay? Z less than minus 0.8. Now we have converted our x value. Still it is same as this, okay? X, not value, x variable into z variable. Now you can find this probability from z table. Because we have converted our x into z. Now z is what? Z is a standard normal random variable with mean 0 and variance 1. Okay, after standardizing any normal random variable, right? Any normal random variable like this here, x is normally distributed with mean, mu, and variance sigma squared. And after standardizing or after converting this x into z, now it is normally distributed with mean 0 and variance 1. So here also we have converted our x into z, which is normally distributed with mean 0 and variance 1. So you can read this probability from Z table. That's going to be the answer for this required probability. So minus 0.8 is what? Minus 0.8 less than, so that is equal to Z greater than plus 0.8, right? And that is equal to 1 minus PZ less than 0.8. So you can read that probability from the table. Here I have shown you the steps. You can try it at home. Okay, I'm not going to take much time from you. So this is the end of the first half of the section, continuous probability distribution. So we will have to discuss only using the, use of the normal table backwards. Okay, it's not difficult. It's really easy. I think I have, I want to take another one lecture to discuss these 3 slides and 5 slides. Okay. Right. I hope you understood today's lecture. So if you have any question regarding today's lecture, you can just ask me by dropping a message or through WhatsApp or by sending an email. Okay. So I'm going to wind up the session for today. If you have a free time slot during this weekend or week, you can let me know. Then I can explain this last section of this chapter within this week. Okay, I will contact your whoever the batch representative is. I will contact him and arrange a lecture with you. Okay, right. So thank you very much for joining the lecture. Have a nice day.